on page 117 in the book, they go through, they take 3 individual students. This is example 2.1. I'm on page 117. And they ask you to calculate the z-score for the 3 students. Now, Jenny's the first student, and she had an 86, I beg your pardon. So that's got to be this score right here, 86. And Katie had a 93, so that's the top score in the class. And Norman had a 72, which is this one, the next to lowest. So we're going to see how these 3 compared to the average person in class. So first thing I'm going to do is calculate z-scores. So for the highest one, we're going to have a 93. So this is going to be z for Katie is 93 minus the mean, which we got from the other page, is 80, divided by the standard deviation, which is 6.07. And if you do that out in your calculator, now I've got to put the top in parentheses, but 93 minus 80 divided by 6.07, and I get 2.14. Now what this means is that this score was 2.14 standard deviations above the mean. So that's real good. And we'll see how good later when we get to the empirical rule, but that's an impressive score. The middle score was for Jenny. So her z-score is going to be 86 minus 80 over 6.07. Which comes out to 0.99, so basically 1 standard deviation. And the last one, poor Norman, gets his 72, so 6.7, and he is going to be a negative 1.32. Now, I got these all in the calculator. So what I'm trying to get used to here is, A, first and foremost, know the z-score formula. All right. Second, be able to calculate a z-score. And as we go on, we're going to get a better and better understanding of what the z-score tells us. And it will be important all year long. Okay, so know your z-score and how to calculate it. One of your homework problems was to do this one in your book. Compare 3 different great baseball batters from 3 different eras. And they give you the relevant information. And this example, I think, actually makes more sense. How do you compare Ty Cobb, who hit in the 1910s, to Ted Williams, who hit in the 1940s, to George Brett, who hit in the 70s? 3 different eras, different types of equipment, different conditions. But if I take each one of these and calculate a z-score, I can compare how each performed relative to everyone else in their era. So again, these are the average and standard deviation for all batters in that decade. And we're comparing their best years, Ty Cobb's 420 year, 1911, Ted Williams 406 in 1946, and George Brett 390 in 1980. So I'll just set up Ty Cobb for you, and I want you to do the rest. All right. So my z-score for old Ty is going to be his batting average, 420, minus the average for his era, which was 266, divided by the standard deviation for his era, which was 0.371. And you're going to get a score. And you're going to set up the other 2 players the same way. And then at the end, you want to be able to say who had the most impressive season for these 3. If you look on page 123 in your book, you've got a picture that should look somewhat familiar. You've got a histogram here, which is what we've been working at. And what you should have picked up on the problems we've already done is that the area, if I add up the area under each of these columns, that will add up to 1. So you had questions on the first test like, if a person got this many, how many people got this many or lower? And I added up all of these columns. Well, what you see superimposed over that now is a density curve. It's a bell-shaped curve. We're not going to say normal yet. We've got to be careful of saying normal. But we use the mean and standard deviation to make this mathematical model. That's what's going on here. So the middle of my density curve will be the mean for the population, and how spread out this is will be determined by the standard deviation. And we're going to be able to do all kinds of things with this model, and we'll talk more about that in class tomorrow. So take these, get those homework done, read the pages assigned, and I'll see you in class tomorrow.